Question 2. A solid compound contains XYZ atoms in the cubic lattice with X atoms occupying the corners, Y atoms in the body centered position, and Z at the center of the face. What is the empirical formula of the compound? A. XY2Z3. B. XYZ3. C. X2Y2Z3. D. X8YZ6 times. Okay, so let's take into consideration of a cube in order to proceed further. Let's assume that this is a cube, and in this particular cube, as we have, let's check with the atom X. Atom X is going to occupy all the corner positions. So it has occupied all the corner positions, right? So X, there are 8 particles. Now all the 8 particles are going to contribute 1/8 part. Okay, it is a contribution, each of them. Therefore, we would say that 8 into 1/8, and that is going to be 1. Okay, so therefore, as it is going to be 1, I can say that X is 1. Let's go with this point 2. Point number 2 is all about the Y atoms, which occupies the centered position. So therefore, let's consider this is the Y. Okay, so when Y particles are going to be at the body center, body centered. Okay, so its contribution is 1. Therefore, Y is equal to 1. Now, let's go with the last one, that is the Z. So in case of Z atoms, they are present at the center of the faces of the unit cells. So center of the faces, 1, 2, 3, 4, 5, and 6. Right? There are 6 faces, so therefore, now, in this particular case, in the case of Z, as it is occupying all the face positions or the face centers, right? So therefore, in this particular scenario, what we are going to get is, as there are 6 faces into 1/2, as every single face is shared by 2 unit cells. So therefore, whatever the particle that is present on the face is also shared by the 2 unit cells. So 1/2, and that is going to be 3. So I would say that Z3, right? So let's combine this all. X1, Y1, Z3 would be the correct answer, and that is the option B in this case.